So hello, everyone, and thank you for joining us today. My name is Sarah Reese, and on behalf of Driven to Protect, we really appreciate you all logging in today. Before we begin, let's take a moment to familiarize ourselves with the technology platform here. You want to go to the next slide, please. In the upper right-hand corner of your screen, you can adjust your viewing settings. We recommend either the stage view or the focus view during this presentation. All attendees are muted on audio and video so that we don't have any unintentional distractions. If you do have any technical issues, please use the chat function along the bottom of your screen, which looks like a chat bubble, to direct your issue towards the host, which is me. And we will also have a moderated Q&A session at the end of the webinar today, so please submit any questions at any point during the webinar using the Q&A function. It will be accessed by clicking the three dots next to the chat bubble and direct your questions to all panelists so that we can make sure to see them come through. This event will be recorded and we will be posting it to dads.org. I will now hand things over to Mr. George Bishop, Deputy Commissioner of the Virginia Department of Motor Vehicles, to moderate today's webinar. George?
Thank you, Sarah. Thank you, and good afternoon to everyone. I hope everybody's doing well and enjoying all of the benefits that springtime brings. Welcome to today's Ask the Experts webinar. We're really excited to have you all join, and I'd specifically like to offer a warm welcome to our fleet partners and fleet participants to this afternoon's webinar. My name is George Bishop, and I am the Deputy Commissioner of the Department of Motor Vehicles. It's quite possible that at some time you might hear another resident of my home in the background. That would be my dog Archie. He's quite fond of alerting me to the presence of other humans and animals on the street, so I'd like to apologize in advance for that if that happens. During today's webinar, we are going to learn more about the work that's being done to bring the Driver Alcohol Detection System for Safety, or DADS, which is an in-vehicle alcohol detection technology system, one step closer to reality, one step closer to eliminating drunk driving and saving literally thousands of lives on our roadways. And you will also learn about how fleets have been a crucial part of this process and how they are a key component on the pathway to consumer deployment. We in the Commonwealth of Virginia are very proud to be the first state to have partnered with the DADS program and to support their efforts to advance traffic safety with this life-saving technology. I'll be moderating the presentation and discussion today. But first, I'd like to start the afternoon off by providing you with a brief overview of the DADS program and the program we have in place in Virginia that we call Driven to Protect. As we all know, the impact of drunk driving in this country is staggering. Each year, drunk driving claims over 10,000 lives just in the US alone. And the societal cost associated with drunk driving in America is estimated to be approximately $144 billion. That's billion with a B, $144 billion per year. The DADS program is researching and deploying a first of its kind technology that holds the greatest potential that we've seen yet to reverse this trend. The DADS in-vehicle alcohol detection technology is a system that passively detects the presence of alcohol in a driver's breath. And if DADS determines that the driver has a blood alcohol limit above a blood alcohol level above the established limit, it will prevent the vehicle from moving, thereby preventing the drunk driver from getting on the road. The program is a result of one of the most important public-private partnerships in recent years, bringing together the automotive industry, represented by the Automotive Coalition for Traffic Safety, or ACTS, and NHTSA, the National Highway Traffic Safety Administration. Now, recognizing the potential of the DADS technology to save lives by actually preventing drunk driving, Virginia has used a portion of our NHTSA Highway Safety Grant funds to partner with the DADS program and to launch the Driven to Protect initiative. Through Driven to Protect, DADS has conducted in-vehicle, on-road test trials of the alcohol detection technology by partnering with the James River Transportation Fleet here in Virginia. And we've been giving Virginians an early look at the technology by bringing a prototype of the DADS technology in vehicles to events around our Commonwealth. Driven to Protect is improving traffic safety and striving to save lives by both deepening the public's understanding of the dangers of drinking and driving, and by helping to develop this breakthrough technology that will one day help to eliminate alcohol-related crashes. So we're excited to share more about this program and this technology with you today. And during this webinar, we're going to hear from 3 different experts as they talk about their involvement in DADS and in Driven to Protect. The rigorous development and testing process behind the DADS alcohol detection technology. Now, this webinar is called Ask the Experts. It's not simply listen to the experts. So there's a structure to it that includes 35 minutes of question and answer, which will occur after about 45 minutes of listening to our panelists discuss about what they're doing with the DADS program. So please make sure that you're participating. If you have questions and wish to have them answered, please do so. I'll let you know how we're going to do that. Many of you have already submitted questions in advance, and we thank you for that. There are a lot of great questions already that have been submitted, but we're also going to be taking questions throughout the webinar, and we're going to do so utilizing the Q&A feature Sarah indicated earlier in WebEx. And now that's accessed by clicking on the 3 dots at the bottom right-hand portion of your screen and utilize the Q&A feature. And when you do so, please, we ask that you direct your questions to all panelists. So you send questions to all of us. If you send them directly just to one, then it might not get seen, it might get overlooked, and we don't want to have your question overlooked. So please direct your questions to all panelists. And we will follow up with the answers to any questions that don't get addressed. We'll try to follow up with you after the webinar if you submit your email address with your question. So when we get there, I'll explain a little bit more about Q&A when we shift to that part of the program. But right now, I want to get started, and I want to introduce to you the panelists that we have for you and ask the experts today. First, Dr. Bud Zalk, who is President and CEO of KEA Technologies. Bud leads a team of independent engineers and scientists who are making sure that the DADS technology meets the standards of durability, accuracy, and precision that are needed for an in-vehicle safety technology. Next, we will hear from Dr. Rebecca Spicer, who is Senior Research Scientist at Impact Research, LLC. And then finally, we will hear from Mr. Stephen Story, who is owner and president of James River Transportation. So to start things off, I'd like to turn it over to Dr. Bud Zalk of KEA to explain how the technology works. Bud?
Sorry, we had muting and unmuting issues. So thank you, George, and thank you, Virginia DMV, for supporting this really important initiative. Just to remind everyone, the DADS program is a public-private partnership between the leading automakers and the National Highway Traffic Safety Administration to develop passive, non-invasive in-vehicle alcohol detection systems for in-vehicle application. The Driven to Protect initiative with the state of Virginia through the Virginia DMV is focused on real-world trial deployments to test these sensors in a naturalistic driving environment through partnerships with James River Transportation. At the DADS program, we've been working on developing 2 types of sensors, a breath-based sensor and a touch-based sensor. The focus of this webinar is the commercial deployment of the breath sensor for fleet application with zero tolerance policy. Below 0.02 is a pass test in this case, and above 0.02 is a failed test. This is an important milestone for the program and is a point along the way of achieving our goal of deploying the sensors for the general public. The real-world data we will collect from fleet deployments will help us inform and improve the next generation of breath sensors that is being developed now for consumer application. So when it comes to measuring a person's breath alcohol concentration, I think most people are familiar with breathalyzers that require drivers to provide a deep lung sample by blowing into a tube or for an extended duration. In contrast, the concept of the breath-based sensor on the DADS program that's being developed for fleet application is contactless. It doesn't require the driver to breathe into a mouthpiece. All the driver has to do is simply provide a directed breath towards a sensor at a distance of up to 16 to 18 inches, as if they're blowing a candle. The sensor then draws the driver's directed breath into the sensor. And then the sensor works by taking that sample, that exhaled sample, breath sample, which measures and measure the concentrations of carbon dioxide and, if detected, the presence of alcohol. The known quantity of carbon dioxide in the human breath usually serves as an indicator of the degree of dilution of the alcohol concentration in the air. Think we're inside a vehicle cabin, so as you're breathing, that alcohol sample or that sample is being diluted, and our carbon dioxide allows us to measure how diluted is that sample inside the vehicle cabin and whether it's a valid sample or not. Inside the sensor itself, these molecules of alcohol and the tracers of, such as carbon dioxide, absorb an infrared light at specific wavelength. Then the device directs this infrared light beams on the breath sample and analyzes the wavelength return to quickly determine the presence of alcohol and accurately calculate the alcohol concentration. Now, verification and validation has been a key aspect of this technology development effort, and it's where we're putting a significant amount of effort and resources. We don't have to only invent the alcohol sensor, the new technology, but we also had to invent some of the test equipment, the test procedures, the human surrogates, and the acceptance criteria to be used. Really a much bigger task than we originally envisioned. The sensor itself has been undergoing rigorous testing using a three-pronged approach so that we can make sure these sensors will work under real-world conditions. We start in a controlled environment inside the lab. We move into a semi-controlled environment, still in the lab, but we're adding the human element. And finally, we go to the real-world environment or in the vehicle, or as I typically call it, the Wild Wild West. In the lab, we test them under limited external variables. These tests provide a baseline for the sensor performance inside the lab. And we test these sensors at high temperatures, at low temperatures, minus 40 degrees, all the way up to 185. We test them at different alcohol concentrations. We go from 0 all the way to 0.12. Some of these tests typically take about 5 days. They're inside an environmental chamber. They're being exposed to all these extreme temperatures and all these different concentrations. But once the lab testing is complete and the sensor is performed as it's supposed to against our internal performance spec, but also against the newly developed SAE-J standard, we send these sensors to the next step, which is our human subjects testing. Human subjects testing involves dosing subjects, taking normal participants that are volunteers in this case that we recruit, and we give them a predetermined amount of alcohol so they can get to a certain blood alcohol concentration, and we ask them to provide samples into the sensor, into an evidential unit, and we also draw blood. We're always looking to compare our sensors with respect to the gold standard, which is blood. So we run these human subject experiment, and they can take up to 7-8 hours per participant, and we run different studies in this case. We simulate real world things like last call, dinner, smoking. We're even running a study currently to evaluate polyuse, so alcohol and marijuana in this case. And what we're looking for here is there an impact? For example, smoking. Is it going to impact the performance of the sensor? Polyuse, are we going to be detecting something other than alcohol in these sensors? Our focus here is calculating the alcohol concentration. So we want to make sure that these sensors not only calculate the alcohol concentration, but they also perform well in real-world scenarios. Once we verify that the sensor performance is good and it passes the human subject level, then we take them from the clinical setting and we send them and start integrating them into our vehicles. We integrate them into what we refer to our human subjects driving vehicles. In this setting, we have a dedicated professional driver driving a vehicle, which is equipped with sensors on both the driver and the passenger side. We dose the passenger to a preset concentration and drive him around for about 4 to 6 hours in multiple environmental conditions. We go on the coast for corrosive environment, we go in the mountains for altitude, we go in the cities at low temperatures, high temperatures. We've been running them now for the past 18 plus months. And this test really represents the real-world driving conditions, but in a more controlled setting, and allows us to understand whether there's any influence of a drunk passenger on the driver sensor, or whether there's any change in the sensor performance over that duration. Because after that 6 to 9 months of running these sensors out in the real world, we take them, bring them back in, we take the sensors, disassemble them, pull them out of the vehicle, and put them back in the lab. And we run them through the same exact test that we've ran before at -40, ambient at 185, with all the alcohol concentrations. And really what we're looking for there is to make sure that these sensors haven't drifted in performance. There's no change in how the sensors are going to work after a longer duration. And we've been doing this cycle now for quite a while. We want to make sure that these sensors are not only accurate and precise, but they're also reliable, and they will last throughout the life of the vehicle. Now, what you see on your screen here is really what a typical fleet installation would look like. There are two components of the installation itself. There's the sensor, which can be integrated. In this case, what you see images of, it's integrated in the steering column or top of the steering column, and in the driver door in this case. And again, once we switch to the video view, you'll be able to see the vehicle that I'm sitting in that represents fleet installation. And I'll be able to walk in more details as well. But it's a seamless integration. The data collection system typically goes under the seat. It's used to power the sensors, collect all the diagnostic data, and transmit the data to our cloud system for fleet managers access. And also to be able to send a pass-fail criteria. These are all customizable settings that we can work with a fleet manager to decide how you'd want to receive these messages. So for example, you can get them as a text message. You can identify the vehicle number. When you have a pass or a fail criteria, it can send you the text message saying, you know, vehicle 1, there was a fail criteria, gives you the time, date, and all the relevant information. But also more importantly, we are getting the diagnostic information of the sensor itself. If we're seeing anything that's unusual and we need to look at more carefully, we're able to get that data remotely and not have to get into the vehicle to be able to get that data. Impaired driving really affects everyone. It's a smart decision to protect your fleet and your customers from potential damage and liability. The early adopters like James River Transportation in this case of the DADS technologies is helping us pave the way for widespread commercial use. It's helping us work through a lot of the issues early on. And both Dr. Spicer and Stephen will talk about some of these early development efforts that we undertook in partnership with the GRT. As I mentioned, the fleet version of this technology is programmed as a zero-tolerance system and is voluntarily offered to fleet owners as a safety option. It's very similar to other systems that you would get in a vehicle today, like driver assist, automatic braking, lane departure warning. And one of the key achievements we've been able to complete this past year is the issuance of the new SAE J standard, which is an important milestone towards the widespread deployment of these alcohol detection technologies in all motor vehicles. I will now highlight and show you guys how the system can be seamlessly integrated with the driving task, how it's seamlessly integrated into the vehicle itself. It's going to highlight how we have been integrating these sensors over the past couple of years into our vehicles, our test vehicles. So what you see is a typical vehicle installation. The orange inlets are there to highlight what it looks like. Typically, we blend the color with the vehicle. You don't have to highlight that. It doesn't look anything different than the vehicle trim in this case. It'll be painted gray, so it matches the trim. But you have a driver door sensor and a steering column sensor. And I'll focus a little bit on the steering column sensor so you can see what it looks like. And in the sensor itself, there are LEDs that provide information or feedback to the driver as they're providing a sample. And I'm going to give a sample now. You can see it picking up my sample as I'm talking, but it's saying it's not a valid sample because I'm a little far. And in this case, for the fleet application, we're going to be providing a directed sample. So all I have to do is give a simple puff of breath as if I'm blowing a candle. And you'll see it blinking and providing the information. And in this case, it's green and it's a valid sample. If it's not a valid sample, it'll blink orange. So for example, I'll give an invalid sample and it still picked it up as a valid sample in this case, which is great. But to show you how far I am from the sensor as I'm giving the sample, this is all I have to do and I get a valid sample. Same thing with the driver door. And again, you see it blinking and receiving the sample. The sensor itself, for example, is integrated inside the door. This is the actual sensor, and it sits below the armrest right here with an inlet and a snorkel that brings the sample into the sensor itself. It's connected to what I mentioned, the data acquisition system, which sits right under the seat in the vehicle and collects all the data and sends that data to the cloud via 4G modem that's integrated on the sensor itself. So that gives you an idea of what a sensor integration would look like inside a vehicle. And with that, I'm going to turn it over back to George. Thank you, George.
Great, thank you, Bud. Next, we would like to hear from Dr. Rebecca Spicer, who will explain the fleet version of the alcohol detection system and the critical role of the technology in reducing roadway injuries and fatalities. Becky?
Great, thank you, George. Welcome, everybody. My name is Rebecca Spicer, right? And I'm at Impact Research up in Columbia, Maryland. So we at Impact Research have been tasked with collecting and analyzing the data that come from the larger DADS program. So I'll just briefly touch on some of the data. We know that in Virginia, around 270 people lose their lives in alcohol-involved crashes every year. And those trends have really not changed much in the past decade. If you compare those trends to the United States, it's about the same. So in the US overall, as George mentioned, over 10,000 people lose their lives in an alcohol-involved crash every year. So the question is, how likely is it that a driver might be BAC positive? And in thinking about that, maybe we can draw a lower bound and an upper bound limit. So maybe the lower bound would be around the rate of alcohol positivity among federally mandated random alcohol testing workers. So these workers know that they are possibly going to be tested for alcohol every day when they come on the job. They are federally mandated, meaning they are safety sensitive workers. And that rate is very low. There's a great deterrent to coming to work impaired. So that's maybe at 0.13%. And the upper bound is likely to be the general population of drivers. And we know based on National Roadside Survey and how many trips Americans make every year, that around 2.11% of trips in the US are alcohol positive. So that's about 4.6 billion trips a year. So 2.11 doesn't sound like a lot, but that's a lot of trips. Now, fleet operators probably fall somewhere in between the upper and the lower bound. Fleet operators are held at a higher standard, but we see often in the field that even with the best intentions to come to work without any alcohol, often those that test positive may have been drinking the night before, come to work with a hangover, still slightly positive. And given that the fleet operators are held at a lower alcohol, that they are at risk of also being positive when they get behind the wheel. So given these percentages, next slide, Eric, what is the risk of crashing if a driver's alcohol positive? So how likely is it that they will crash? It doesn't take much to be impaired. So this slide shows you that at 1, there's no and we know that even at as low as 0.02 to 0.04, there's over 2 times greater likelihood that a driver will crash. And that likelihood, that risk, increases with increasing BAC levels. If you're over 0.15%, it's 22 times more likely to crash. So given these risks, we've taken a look at, we've asked the question, if all the drivers that were BAC positive were sober, next slide, Eric, please, we would estimate that about 1,169 deaths would be prevented over 5 years in Virginia if those drivers with a BAC greater than 0.02 were driving sober. So that's a lot of lives. Next slide. So what is the burden of these alcohol-involved crashes? Research shows us that alcohol attributable crashes in the US result in $144 billion in medical, lost productivity, and quality of life costs, and an additional $2.1 billion in adjudication, sanctioning, and legal defense fees. So these costs account for 23% of societal costs of all crashes, and they account for 22.5% of US auto liability insurance payments. And one thing that we do know about alcohol-involved crashes is that they are more severe and more likely to be fatal. There's a greater burden if alcohol is involved in a crash. And this is usually because alcohol-involved drivers take other risks like speeding, not wearing seatbelts. So those crashes generally are more severe. And what's the average cost per alcohol-involved crash? It's about $74,659. And that's an average of all alcohol-involved crashes. This includes the medical, emergency services, lost wages and productivity, insurance administration costs, property damage, and quality of life costs. And those quality of life costs are the monetized value of the pain, suffering, and lost quality of life that a victim or a family would suffer due to disability or death. Now, these costs do not include legal and liability costs. And from a fleet perspective, the legal costs of a severe alcohol-involved crash is likely to exceed liability limits. So this is certainly something to consider when we're looking at costs. Next slide. So we have taken a look at an estimate of the DAD's return on investment. We estimate that to acquire and install the alcohol sensor in each vehicle, it's around $700. And making some assumptions about the prevalence of driving alcohol involved and the risk of crashing, we estimate for every investment in a sensor in a vehicle that the return on investment is about $252 per year. And these are savings from crashes prevented. So that means that after about 3 years, the $700 investment is returned. And again, these savings do not include the legal and liability costs that the fleet operators and fleet owners will have to consider. So we've touched briefly on the James River Transportation Demonstration Project. And Stephen Story will tell you a little bit more after I'm done presenting what we've learned from this project. This demonstration project is collecting naturalistic driving and sensor use data in uncontrolled test conditions, so in real world test conditions. And the objective of the program is for us to better understand if the system is generally accepted by fleet operators. Are there any technical modifications that are required to improve the actual systems? And finally, is the system ready for wider implementation in the fleet or privately owned commercial or other vehicles? And what we've learned is that the project has really helped us refine the performance of the sensors, the performance specifications, and also the data acquisition systems for future on-the-road vehicle testing. The James River Transportation Project has collected nearly 50,000 samples from their fleet operator. And over a period since we began the project, James River Transportation has also implemented 2 different generations of the sensors. So we've been able to see if there's been improved performance from generation 3.1 to generation 3.2. And just the feedback that we've received from James River has really helped us continue to improve the sensors and understand what it means to implement these systems in a real live fleet. So we've spent some time talking to the fleet operators, the James River Transportation operators, and we asked them a little bit to try to understand how receptive they are to the sensors in their vehicles. The drivers, for the most part, had a positive perception of the technology. They understand the need to reduce alcohol-involved driving on our roads. They most said that they are willing to be delayed by waiting for sensors to be ready or by taking the time to provide a breath sample. Now, when we talked to the drivers, this was still generation 3.1. So in the meantime, we have been able to improve the speed at which the sensors process the breath sample. We asked the drivers more about whether they thought it would save lives. And as one driver said, he thought it would prevent 90% of crashes. And they really felt like their contribution to the development of these sensors was for a good cause. We asked about the passengers' response to the sensors. You saw that Bud showed you the orange sensors. Now in the JRT vehicles, those sensors are gray. They meld into the background, the door, it's gray. You can't really see it's an actual sensor, but you can see the little blinky lights showing that there was an accepted or a not accepted breath sample. And so occasionally passengers were curious. And so we asked what the response of the passengers was. We provided the operators with a brochure that they could show to the passengers or give to the passengers so that they would understand what they're doing. And the passengers actually were really mostly positively receptive. And they also felt that even that being in a James River transportation vehicle where they're actively making an effort to keep things safe for their passengers was a really good thing. And the other piece that we were really interested in is how the drivers are interacting with the sensors, the human machine interface. And we did learn that there's a small learning curve in providing a sample to the sensors, but after a short time, I got the hang of it, as one driver said. They felt it was really easy to provide a breath sample to the steering rather than the door. One operator said the door can be kind of funny. And they felt we are always concerned about distractions. So we did ask about the lights, the blinky lights, and they felt that the orange and the green lights in the sensors were informative and they did not feel they were a distraction. So this is what I wanted to share with you today, and I'm open for questions later on after we're done. But George, I'll pass it back to you.
Becky, thank you so much, and it's fascinating to hear the data, and I love hearing about the reaction or the comments, feedback from the drivers, and how they reacted to technology, but being part of the dad's pilot. But before I turn it over to Stephen Story to talk about ART and their experience with the dad's program, I do want to mention once again, about the question and answers. So just in case you were curious, again, if you want to submit a question, make sure that you access the Q&A feature on WebEx by clicking on the 3 dots that are down in the bottom right-hand portion of your screen. And remember to submit your questions to all panelists, and if you would, to add your email address to the question so that if we don't get to it in time, that we can follow up with you with an answer after the webinar is over. But now I'd like to turn it over to our third panelist, and I'd like to thank him and his company, James River Transportation, for being such wonderful partners, not only with DADS, but also with Virginia DMV for many, many years. The president, CEO of James River Transportation, Stephen Story. Stephen?
Thank you, George. I appreciate that. And thank you for everyone else. Thanks for taking the time to come listen to our panel today. So James River Transportation has been a proud staple of the Virginia business community for decades. Just a few short years ago, we celebrated our 90th anniversary, and this is a multi-generational family-run business. We already use a large variety of technology for safety and efficiency. We use a driving simulator, a digital driving simulator, so our drivers know how to react quickly in case there's a tire blowout or equipment failures or adverse weather conditions, so they're able to drive throughout all of that. Our vehicles have event recorders so that we can monitor the driver performance and coach them as needed, and as well as tracking speed and idling of the vehicle too. This video is monitored by artificial intelligence nowadays. So the video feed can determine if there's distracted driving, if the vehicle is drifting in a lane, if there's a following distance issue. So artificial intelligence has brought a whole new level of technology to our safety and operations. Our smartphones are now our main communications platform throughout our organization. We use it for electronic driver's logs. We use it for the vehicle inspections, and our safety and emergency checklists and our company policies are all embedded into that company safety app. And it's also the portal for our safety and customer service training modules that our drivers and all of our team goes through. Safety of our passengers has always been a priority. Everything that we do in our organization, every decision that we make is based on a safety-based decision-making process. You can ask any of our 150 employees throughout Virginia. It's part of our culture. So when we first heard from Virginia DMV that it was looking for a partner who could help test this new alcohol detection technology in real-world settings, we were eager to join. As George had mentioned, we already had a partnership with DMV. We've tested other technology and other policy updates. So it was really a good fit and a natural fit for us to work with DMV. The technology that Driven to Protect is helping to advance is an innovative way to reduce and really hopefully eliminate alcohol-related injuries and deaths. The alcohol detection technology provides peace of mind for fleet owners like myself, managers, and drivers. And I'm really proud that James River was in the forefront of introducing this safety technology. So I wanted to kind of give you an overview of the work happening in Virginia with this technology in our vehicles. Since 2018, James River was started working with Driven to Protect initiative to conduct this in-vehicle, on-the-road test trials of the DADS technology in our fleet vehicles. So engineers have installed prototypes of the breath-based sensors into 4 of our vehicles, 4 of our airport vehicles in the James River fleet. And these vehicles ran the same schedule, did the exact same thing as all the rest of our fleet did. James River DADS vehicles, they drove nearly 52,000 miles, and gathered more than 47,000 breath samples from our drivers. James River drivers would provide breath samples to act as a baseline to assure data accuracy. So they do this when they're starting their shift out. And then throughout the day, they provide additional breath samples in different environmental conditions, like we talked about, like Bud talked about, gathering more data to really improve the system. So by being in this real world environment, we could try it out in different temperatures. We could try it out closer to the beach where we could experience some salty air and high humidity, low humidity. We travel into the mountains, so the pressure was a little bit different and the temperatures were different there. We could try it out with different cleaning products. 2020, we experimented with a lot of disinfectants, and we could see how that interacted with the technology. Some drivers regularly use mouthwash. We know that that possibly could affect the sensors, and we were able to try that out. One of our drivers determined that in the initial stage of the program, there's a cooling fan in the device, and it caused a slight frequency interference with his hearing aid. So we were able to really get real world testing to benefit and make this program and make this device even better. So throughout the testing, improvements were identified, improvements were implemented to make the system user-friendly for fleet operator, for fleets like ourselves and consumers. So now a James River driver and other fleet drivers only need to make that one easy breath sample to starting the car. So really simplify the process through all of this testing. So you've already heard some of the positive driver responses through the interviews and group meetings and group sessions. But our drivers really were excited to participate. I challenge them on a regular basis. We try new technology all the time. So that wasn't too different for them to experience. But they're excited to work for a company that's using cutting edge technology. They're excited to be part of the solution in helping save lives. And that's really, really important from a fleet owner perspective. It's important to our safety culture to be part of this, to be part of the solution, but it has to make financial sense. We know this, to install the technology. Just like all the other technology devices that we use, it has to make financial sense. For me, I see DAD's equipment invaluable in fleets where drivers sometimes report to work early in the morning, and there are few to sometimes no supervisors to interact with them. So, none of us as owners, none of us think a driver is going to drink all night and then purposely come to work and report to work the next day. But we also know, and we mentioned this earlier, or Becky did, that, there's times where your friends stay over late. The game goes into extra innings. You have that one extra beer during all that time. And it's very possible that a driver could show up to work the next morning with alcohol still in their system. So beyond the savings in the injury, in the vehicle damage, that's the obvious part. But we know there's a real cost. A fleet owner knows the potential for liability claims in lawsuits, and especially if that dollar amount exceeds your insurance limits. So just wanted to share that information with you guys. I appreciate, again, your time that you spent with us, and I'll stick around for any questions that we can participate next, coming up. George?
Thank you, Stephen. Thank you to all the panelists for your presentation. We really appreciate it. We have received some great questions, but we will continue to take questions in the Q&A section of WebEx as we continue. So if you have not already submitted your questions, it's certainly not too late. We have about 45 more minutes, as it turns out, to answer some of these questions and to hear from our experts as they answer any questions you might have for them. So I'm going to go ahead and just get started with some that have already been submitted. The first one I think I'd like to ask is to Becky, Dr. Spicer. the question comes, is there actually a drunk driving problem among fleet operators? We've touched on this a little bit, but we know because we drive around and we see people using telephones and distracted driving. We see distracted drivers all the time on the roads. It's less easy to see that somebody's actually impaired from alcohol use while you're sitting next to them at a stoplight. But what does the data show us? What is our drunk driving problem amongst fleet operators?
Well, to answer that question, I am going to put my little research hat on because I've spent some time working in the workplace in preventing alcohol and drug abuse. And we do know from workplaces that those workers who are more at risk of either using drugs or drinking are those workers who are not supervised on odd schedules. And those kind of fit the fleet operators. There are other risk factors like being in proximity to alcohol or drugs and other risk factors. But those two pieces put fleet operators who are in those odd hours of working and unsupervised into that risk category. Now, I did try to think a little bit about where fleet operators may fall in that likelihood of being of drinking while driving, and I do believe they are less likely than the regular driver on the road, and more likely maybe than those safety sensitive workers who have everything at risk if they're test positive on a random test. So it probably depends on the fleet. And we have made that point that often some workers will come to the job after having a night of drinking with friends, and they just don't realize that they're still alcohol positive. And even at a 0.02, 0.03, 0.04, there is an elevated risk of crashing. So put that all together with the risks that fleets take in being on the road for as many hours as they are, that is certainly something to consider.
Yeah, I was fascinated by by the slide that you put up, which showed the level of risk associated with a very small amount of alcohol on board. The 0.02, 0.03 that you were showing, that the driver was 2 times more likely, I believe, to be
right.
involved in a crash, all the way up to 21, 22 times more likely if they were severely impaired, 0.15. But even at that low level, which I think is fascinating, and I think is a detail or a fact that is not well known societally.
Yeah, and that is often because our laws are generally 0.08 and 0.05 in Utah for a regular driver, and by that point they're severely impaired. So it is important for people to understand that impairment happens quite early with alcohol on board.
Yeah, thank you. But there are a lot of questions about the technology itself. But I'm going to try to combine a bunch of the questions. There are a lot of people out there who are very concerned that drivers are an ingenious lot, and that they might somehow try to bypass the system. I can't imagine that a driver might try to bypass the system but so the question is, there are a lot of questions related to that about, how does the system tell the difference between a driver and a passenger? What about if a driver is trying to bypass the system somehow? How can and then what if the driver is somehow using alcohol after the car is already started and underway? How does the system then detect if a driver has alcohol in their system as the car is already moving. So can you talk about a little bit about some of those issues surrounding the,
Absolutely.
yeah, go ahead.
Absolutely. I mean, let's start with the first one, which is, if you have a passenger or drunk passenger, or if you're a fleet operator and you have a car full of drunk passengers, is that going to register on the sensor? And the answer is no. The one good thing is that there's a large dilution factor. What that means is, as those alcohol molecules traveling in air all the way towards the sensor, towards this corner of the car, they get diluted. The car is not a sealed environment. As much as we'd like to seal it, it's not fully sealed, and there's still air circulating in. So the air exchange dilutes those samples. We've done experiments, we've done a human subject studies where we have drunk passengers, and we don't see any impact on the sensor itself. Now, that also helps us triangulate that it's the driver given a sample in terms of circumvention and tamper proof. Without a doubt, there's always going to be a community of people that are going to try to tamper with a sensor like this. I think from a fleet application perspective, there are a couple of countermeasures that you can implement. These include, video monitoring, monitoring of when the sample is given and the type of sample. We are looking for carbon dioxide. We're looking for human breath. You have to have what we've developed in our lab, which is, the size of a big toolbox, a mechanical lung that gives you an exact profile of what a human breath is and exact pressure of where the boundaries it fall in. You'd have to have the ability to actually dial in that the peak of carbon dioxide matches the peak of alcohol or doesn't match the peak of alcohol. So it becomes a little more complicated to defeat it. It doesn't mean that that's not going to happen. I think it's something that we're going to be constantly looking out for and trying to adjust and trying to implement tamper-proof mechanisms along the way.
So just for an example, that the system would be able, if you use some sort of a device that would just blow air, right? Like one of those things you could get to like blow off your computer screen or keyboard,
Yeah,
that kind of thing.
that's just
That's
not
not
going
going
to
to
work.
fool it because
No.
it doesn't detect the carbon dioxide or something, like not in
Yeah,
the
exactly.
quantities that you would expect in human breath.
Exactly. And even if it's a can of carbon dioxide, it has to be adjusted to fit the profile of a breath, a profile of a forced expiration or profile of a passive breath to be able to detect that. Another thing I do want to mention, and you ask about, is the ability to detect alcohol. If after you've screened the person, you start the vehicle, they're driving, they open a can, or they start drinking alcohol along the way. So again, I'm going to talk a little bit about fleet and about the consumer version. So the consumer version is designed to be passive. So in the case of the consumer version, which is coming down the road in about 1 to 2 years, it's a fully passive sensor. So as you're breathing normally, talking normally, the sensor will pick up and calculate alcohol concentration. If there's presence of alcohol in the cabin, it will pick that up, whether it's out of an open container or whether it's out of someone breathing. It will pick that alcohol concentration and be able to calculate. And you'll be able to know that it's a human person, it's a human being versus a bottle of vodka, because when you open that bottle, the amount of alcohol is going to be quite excessive. And it's going to pick up that sample, but alcohol also dissipates pretty fast. Unless you keep the bottle right in front of it, you're going to see this dissipation quickly over time. So it allows us to develop these algorithms that's going to identify the presence of an open container versus somebody that's actually drunk and breathing towards the sensor. On the fleet side, at the moment we are setting the sensor to be zero tolerance, to be directed breath. At the same time, we can also have it in a sniffing mode. And what that means is, again, if it detects large quantity of alcohol, in this case an open container, it could flag that as an open container or as a presence of alcohol. It won't be able to quantify it. It won't be able to tell you where it's coming from, but it will say there's alcohol and it's in a larger amount. So something, I send a notification to a fleet manager or a supervisor or anybody else that's involved in the chain of command.
Okay, and so there's also been a question about the video and using the video system to determine if a driver was trying to defeat the system, I guess, in a fleet application. Do we have a video that's integrated into the system?
we've had options, and we offer it as an option today. Obviously, with video comes other considerations that we have to take into account, privacy being one of them, specifically on the fleet side. I think that's always a conversation with the fleet manager and the fleet application itself. It all depends on what their preference is. What I've seen is most fleets today are starting to use outward-facing cameras and inward-facing cameras. It's becoming more and more of a common application. It's not in every fleet provider, but it's becoming more and more common. And as it becomes more common, it becomes a lot easier for us to be able to develop these algorithms or implement these algorithms that would tell us that, yes, the driver that is sitting in the seat itself is given a sample into the sensor and not somebody else. It allows us to implement a lot of these countermeasures.
And Stephen, specifically for you, what is JRT doing with video analysis systems? Does James River Transportation incorporate video analysis into your vehicle safety, driver safety, and if so, how?
Yeah, well, when we first started implementing this program and testing the technology, the DADS program did implement videos in there. So we wanted to see the driver taking the breath sample, so that if there was anything odd in the breath sample after it was analyzed, that we could determine, one driver might blow harder than the other, it might be a closer proximity, and we could also determine if there was a detected alcohol, why it was detected, whether it was a can in this case or something. So early on, the video was devised to just do the test and monitor the system and to provide a lot of additional feedback. Now, again, we've moved into the second stage of that. The videos have been eliminated from the DADS program because the technology has been improved so much. But from a company standpoint, from a James River company standpoint, as Bud had mentioned, many companies have already implemented, video performance and video event recorders. We had it, we've had ours for, multi years, probably 10 to 15 years, we've had video equipment. And now we're at this next stage where it's kind of, we can see live things going on, we can log in. So video is much a part of what's happening inside the cabin environment, what's happening outside, driver performance of other vehicles on the road. So, nowadays, again, as what Bud had mentioned, video event recorders are highly sophisticated units that you can almost ask them to monitor and do everything. So yes, we kind of did both. In the early days, it was to kind of help perfect and help test that technology, to provide that extra set of eyes, to watch that technology, that new technology in action.
That's great, and I'm gonna stick with you if I can for a minute, Stephen. Well, first I want to ask, during COVID, did the drivers have problem with hand sanitizer? You mentioned about the Listerine mouthwash, yeah. Did they have problems with hand sanitizers causing an issue with the device?
Yeah, as long as they didn't drink the hand sanitizer, I think they were okay. But
yeah.
So one of the issues that we found, again, early on, and we suspected, and Bud and his team suspected, that mouthwash, might detect it. Hand sanitizer, I mean, we used hand sanitizer before COVID. We might not remember that, but it was around at one time.
We did, yeah. Some more than others.
Yeah, but what would happen, and because we had a positive go off one time, and it kind of made me nervous, thinking that there was a possibility. But what happens is, and kind of Bud had mentioned this, when you have a high alcohol concentration of a product, whether it's mouthwash or vodka or something like that, the numbers peak up, and then they go down really quick. So if a driver used mouthwash in those early test days and breathed into the sensor and it detected a really high number, not a normal number, but a really high number, like he shouldn't have been walking type of number. But then shortly thereafter, then it went back down, within, seconds to a minute or two, secondary breath sample, it goes back down. So again, that's part of that whole testing process. But you know, we still sanitize our hands. We still use UV lighting. So that was something new that wasn't quite sure how it would affect, because our UV lighting that we use within our vehicles to help us sanitize and disinfect with COVID around last year provides this ozone type of smell and the ozone type of air quality, and we weren't quite sure how that was going to affect it. But again, that's why we're doing all the testing, because there's always something that, you know, maybe we haven't thought of, or maybe a lab tech hasn't thought of, and that's a good part of this testing.
So thank you.
And maybe,
Yeah.
so George, I'll just add briefly to Stephen, is that the sensors themselves are tested against all these what we call interference inside the lab. We want to make sure that nothing else like methane, methanol, anything that's going to interfere with the sensor is going to impact the measurement. So we do perform all these tests per standard that's developed to make sure that there is no impact of anything that you're going to do inside the vehicle. Even new car smell is tested against, you know, in these sensors. So we do go through that rigorous testing in the lab as well.
Great, thank you. I'd like to switch gears and talk a little bit about data. And I'd like to talk about all three of our panelists. I think there's a portion of this question that I'd like for all three of you to address. I guess the first part of it, I think I would like to address to Bud. And it's really kind of twofold. One is you've mentioned and you've shown examples of data collection, and you talk about data being collected and then put into the cloud. So the question is really, you know, can you give us examples or details about what data is being collected, who gets to see it, how it's being used? That's part one. And then part two is, can you explain to us the difference between the data that's being collected during your JRT, we call it a pilot, but during this real world, you know, I call it dads in the wild, as opposed to your controlled environment. This is a naturalized or sort of in the wild environment. And what's the difference between data collection in you know, in this phase of dads, and then data that might be collected, you know, once it's being offered to fleets or the consumers and that kind of thing? There's got to be a difference between data collection and how it's being used and implemented or stored or all that kind of stuff.
Absolutely. I think there's a big difference, to be honest. So I'll start with the vehicles that we have, even before jumping into JRT and Stephen's vehicles. So the vehicles that we have, we collect all kinds of information. We get temperature, we get HVAC, so heating and air conditioning, what temperature, what fan setting, windows open, windows closed, sunroof open. We collect outside temperature. We collect inside temperature. We get all kinds of messaging from the car itself. So we actually connect to the vehicle CAN interface, because these are vehicles that were provided to us, and we've been working with the auto manufacturer on you know, in terms of they provided all that access to us. So it's a wealth of data, and it's important for us in the development that we have that data, so we understand that what's the impact of opening a window versus, you know, the window closed? What's the impact of having an air conditioning on or heater on, and the different settings? So all those are critical. We also collect the status of the vehicle, the speed, you know, everything else. So, and that's research data. That's really focused under the DADS program, the research data. Now, the next level is what we talk about, the development effort that we've been working with James River. And there we're really collecting multiple things. So we use a reference sensor. So we ask the drivers early on, we would ask the drivers to give us a sample into our sensor and a sample into our reference sensor. We collect that data. We actually get the raw signals out of the sensor, and we do the analysis on board and in the cloud to make sure that our algorithms are working properly. So our alcohol concentration, the details of that is being calculated. In this case, we're getting the actual raw value of the carbon dioxide channel, the raw value of the alcohol channel, the raw value of the board itself. What's the temperature of the board? Is the environment too hot, too cold? What are we seeing there? Not to the level of that we get out of the vehicle. We don't collect any of the vehicle data because in this case, we don't have access to the vehicle CAN network. Now moving to a fleet application. In a fleet application, it's really a pass-fail criteria and diagnostic data is all we're going to be looking for. Now the data collection system has the ability also to provide you a GPS location with other information on, the vehicle itself. But, from a simplistic perspective, the main focus would be pass-fail criteria diagnostic and the ability to send that data to a cloud-based system or to a phone, to either via text, via email, or potentially via phone call, but primarily text and email. And that's what's going to be mostly the focus of the fleet application. Very limited data, very focused on the job of what the sensors are there to do, and providing the fleet managers with the information that they need. And we can tailor that to how they want to see it and what kind of information they want to see.
So that was going to be my question to Stephen then, and it's a great segue. So Stephen, from a fleet owner, fleet operator perspective, your interest in the data is really just that is what? What is your interest in the data? I would assume it would just be that pass-fail kind of data.
Yeah, that's correct. For us, it would be pass-fail. Obviously we had a lot of inside information on all the data that was being collected, but that was from a testing type of standpoint. But yeah, from a fleet manager, safety manager, I would want to know notification, pass-fail, notification, soon as possible, quick and to the point. So, and I think that was part of a little bit what you're getting at too is data is sensitive nowadays, and everyone's concerned about what data is shared. And as a fleet operator, I would be concerned about that too. So I would want that data pass or fail and not to be shared out. And to Bud's point, they recognize that it's that the fleet owner wants a pass or fail, and all that other data remains or does not get collected.
Right. And Becky, as the data is concerned, and from the JRT deployment, from someone who is analyzing that data, what are some of the findings that have either surprised you or that you have found to be most significant from this deployment in JRT and the literally years worth of data that has been collected from this project?
Yeah, I think so the most surprising part really was that, especially with the 3.2 generation, is how few false positives we get, and how easy it was to identify with JRT's help when someone who had been using a mouthwash or a toothpaste that had like a mouthwash base, figure out what that profile is when you look at the sensor reading. So as Bud and Stephen mentioned, the profile, the sensor readings for someone who's taken in mouthwash, they're super positive at one point, and then it drops off very quickly. And that was really a really valuable finding that we were able to implement moving forward. And I think the most heartwarming part for me, actually, and I know that wasn't your question, but the most heartwarming piece for me was talking to the drivers. And the drivers, being on the road as much as they are, they have had encounters with other alcohol impaired drivers, and they know how serious a problem it is. And so the most heartwarming part for me was how happy they are to be being a part of the solution, really. So
I would just like to point out how great it is for me to hear in the middle of the discussion about data, the term heartwarming. That's refreshing, and I love to hear that, Becky. Thank you.
You're welcome.
So, Bud, I'd like to swing back to you if I could. you did talk about integration into the vehicle, but one thing we haven't really talked about much is maintenance and service. And of course, there, you know, in any vehicle, in any operation, maintenance and service is an ongoing part of operation. What do you anticipate to be the maintenance and service on DADs in a vehicle?
Yeah, again, I'm going to put it in two different applications, right? Fleet and consumer-wide deployment. From a consumer-wide deployment, the goal is life of a vehicle, no maintenance. So that means 187,500 miles or 15 years as defined by NHTSA, no maintenance. The sensor is in there, it's working day in, day out. The only thing that we might consider, and we're still in the process of evaluating that, is a small filter that will sit in the inlet to prevent, extend the life of the sensor. And it's the same thing on the fleet application. The sensor is designed for the life of the vehicle. It is an IR-based sensor, which is pretty stable over a long duration. You know, you can think of it as a small light bulb that's going to be not constantly on, but on and off, you know, cycling over duration, and it will last throughout the life of a vehicle. I think initially what we're going to want to do is, as we deploy these sensors, we're going to want to bring them back after a year and just make sure everything's still running okay. We're not going to calibrate. We're not going to do anything with it. There's not going to be any calibration requirements, but it is designed to live over the life of the vehicle. And early indications, data that we've seen so far tells us that we're not going to have any issues. It is working. There's no drift, no change in performance. We recalibrate, you know, we recharacterize them when we bring them into the lab, and the performance is spot on as we had them when we first got them and did all these tests. So, and the other big part also to keep in mind is these are very fast sensors. So you give a sample, it gives you the results. It's almost immediate, you know, less than a couple of seconds. So you don't constantly have to keep them on. So that will extend the life of the sensor as well.
George,
So, yeah.
George, I'd like to comment on that. So early on, you know, we were looking at the devices and thought, well, okay, we'll be prepared for a little bit of maintenance because it's a new product, it's being tested. But we were all, our safety manager and myself, we were all shocked because we really had very few issues, and really the issues that we did have or the maintenance that was done were updates. It was either software updates, improvement updates, you know, things of that nature. So, you know, coming right out the gate, they were very reliable for us and didn't cause us any maintenance issues whatsoever.
That's great. Thank you for that, Steve. So, Bud, there's some questions about really about a timeline. You know, when we can expect this technology to be ready for widespread use, and widespread use, I guess, meaning consumer use, but also if you could weave into that answer, I know that there's a difference between a fleet timeline and a consumer timeline. There's a difference
Yes.
between an aftermarket installation and a original manufacturer installation. So can you give us some kind of you know, what to expect in terms of timeline for those kinds of things?
Absolutely. So the consumer-wide application, what we refer to as Generation 4 sensor, is scheduled now for 1 to 2 years from now. That's what we're working towards. That's the timeline we're working towards, and that's going to be a smaller sensor. I showed, the sensor that we're using today, and this is the actual package. Now think that something like this is harder to integrate into a vehicle than if you have half the size or even smaller. The footprint that we're looking at, the package size is much, much smaller. We're looking to go less than 50% in size. And that's going to open up the integration for the automakers and the suppliers and make it a lot easier to add. So our goal to have it available to the automakers to implement in their vehicles within the next 2 years. What that means also to keep in mind is that that's us giving it to the automakers. The automakers still have some internal work to do in terms of integration and implementation. And it's highly dependent on what platform is about to roll out at the time. So it's hard for me to answer that part, but from our perspective, about 1 to 2 years, we'll have that sensor out. Now, from a fleet application perspective, we are driving towards, and we are pretty much on time. We'll have this ready by the third quarter of this calendar year as a commercial application, as a unit that you can buy off the shelf. But in between now and then, we are working with fleet providers to integrate some trial deployments, to start some trial deployments, small scale number of vehicles, 3 to 4 vehicles that they can test out and understand how the technology works, because it's going to help them really get a sense of what's the technology capable of doing and what it's not capable of doing, and how it's going to work in their own environment. So I would say we are working at the moment with a lot of fleet owners and fleet operators, and would love to work with additional fleet owners. We are always looking for different environmental conditions, climatic conditions. So, if we have people in Texas, that's fantastic. Hot temperatures. We have people in Nevada, that's fantastic. In Alaska, that's fantastic. All those are very helpful for us. But the goal is the third quarter. And as you mentioned, there are 2 different flavors of integration. There's the fully integrated, as you see here, but there's also what we call a fixed add-on. So essentially, it's just added onto the vehicle. It's going to look like a small block that's going to sit on the dash somewhere and fixed, and you provide a sample towards it. And that's an easier integration because in this case, we're not opening the inside of the vehicle to integrate these sensors. So there's options. Fleet owners have options. Again, trucks are simpler to integrate because there's a lot of space around them, the larger trucks. Passenger vehicles like this are more challenging to integrate into. But as we work more and more with the automakers, this will be a lot simpler to integrate as well.
And Stephen, in your vehicles, this question really is about what types of vehicles you might be able to put this into, makes, models, passenger vehicle, truck vehicle. Stephen, the vehicles in your fleet were Ford Flexes, correct?
Correct. Yep. So we opted when we first started to implement this. We opted for the most universal type of vehicle that would meet like consumer demand, and that ended up being a Ford Flex. We have passenger vans, like a 15-passenger Ford Transit van. We also have Lincoln luxury type vehicles. So the Ford Flex just ended up being that nice medium style, and we used it more often. So we could generate the most miles, generate the most activity in a shorter period of time. But I think, like Bud was saying, we also have a large variety of vehicles. We have shuttle buses, we have full-size tour motor coaches, and again, I think those are all options that Bud and his team can work with. And we started out with just that passenger vehicle. So we have a little bit of a challenge because we only have a year left on those Ford Flexes before we have to refresh them, and Ford no longer makes the Ford Flex anymore. So we'll have to figure out what our replacement vehicle is. We're all sad to see our Ford Flex leave our fleet in a year or so.
But Bud,
But I think,
yeah, go ahead.
So I think to Steven's point, we also went through 2 different model years of the Ford Flex. I think you had the 2015s. We did quite a bit of mileage on that one, and then we transitioned from the 2015s to the 2019s, if I recall. And we've been doing quite a bit of mileage on that, and now those are going to be phased out. So it's been through multiple model years.
Those 2015s, I made a good deal to my son and daughter, and I was trying to talk them into letting the technology follow the vehicle along to their vehicle, but we had to transfer that technology to our new models.
But okay, so Bud, I guess to try to answer the question, and I think it really, if the question is which model year and model makes would be eligible, it's really not so much that. It's really how would you take what a fleet operator might have, and then how would you then figure out how to integrate your technology into it? How would you do that? I know how you did it with JRT, but maybe you can share that with us. How much time did it take you to figure out how to integrate that type of thing?
Yeah, so I think, if it's fully integrated into the vehicle, it's a little more involved, and that's typically 3 to 6 months of engineering time that we would have to do, where we actually have, we look at where it's going to be positioned, we develop the engineering drawings, and then we integrate the sensors and deploy them. But if it's an add-on, like I talked about, what I call an add-on fixed installation, then it's pretty straightforward. It's just finding the spot and adding it on, and putting in the equipment, and that's a much, much faster and easier and lower cost integration as well, versus the fully involved integration.
Well, I'm glad you
To be
brought up.
honest, sorry.
No, go ahead.
To be honest, the sky's the limit. I mean, we can do any vehicle, truck, bus, van, you name it. It can be in it.
So I'm glad you brought up cost, because that is one of the questions that I've received. And so the question is really, what is the cost for integrate? Well, what is the cost of the equipment if I'm a fleet operator? And you mentioned it, so I'll ask, what is the cost differential between the integrated and the sort of aftermarket box that you would put on the dashboard?
So let's start with the cost of a fixed install, what I'd call the outside install, and we're targeting somewhere around the $700 a unit, and that doesn't include any calibration or any maintenance. There's nothing involved in that, right? That's just a one-time cost, and that's all you have to worry about. There are no mouthpieces that you have to buy. There is nothing else there. It's just a sensor sitting in the vehicle. And that's our target. I think Becky showed some of that data in terms of return on investment. That's our target for when we deploy it. Now, as we go into integrating inside the vehicle as I have it, that's really highly dependent on the vehicle itself. I'll share, for example, with JRT, they had Ford Flexes, and Ford Flexes are nice and big. The door trim, plenty of space behind it. You can integrate a sensor. You can fit all kinds of stuff. The vehicle that I'm in, very, very tight. Not a lot of space, requires quite a bit of engineering. So it's hard to be able to give a dollar amount, but it's really based on time and how long it takes us. It could get expensive. We try to keep it as low cost as possible, and especially now that we've had a lot of experience with different various models. We've done it in RAV4s and Fusions and Flexes and Malibus. We've done it in a variety of vehicles. So we have those templates available. And then the other part is also, is it one single make and model? Do you have 10 vehicles of the same make and model? Then it makes more sense to integrate, because now you're splitting the cost across 10 vehicles and not just one of each kind. So that's, like I said, it really depends on the fleet and what they're looking for.
Right. Thank you. Thank you. What are some of the, and again, this is a two-part question. What are some of the major milestones in the development process that you see? I mean, we have talked about, getting, you've said third quarter, we're looking at being available for fleets, and then 2 years for consumer. And then there's also this other brand of DADs that's not breath-based, but is based upon touch. So can you kind of talk a little bit about the major milestones that you have in front of you next with the breath-based, which I assume is on the faster track than the touch-based, and then very quickly touch on the other variety of DADs, which is the touch-based.
So as I mentioned, the goal for commercial deployment, and I'm talking available in from a commercial perspective to buy and install in vehicles, for the fleet application is the third quarter of this year. It will be available to be purchased and installed. The consumer version, I would say about 2 years, 1 to 2 years. The goal is to transition and give it to the automakers for them to integrate. Along the way, we have quite a bit of work. I think everybody's aware of this pandemic that we've been having. That's why we're here in a webinar format. And that hasn't really slowed us down. The one thing, from a development and testing and everything, it's really been, we've been pushing forward with no delays. The one thing that has slowed down, obviously, primarily because you're dealing with humans, is the human subject testing in the vehicle and the human subject testing in the clinical environment. We're starting to resume that. We've resumed our human subject testing in the clinical environment. Our hospital staff are now all fully vaccinated. Our researchers are vaccinated, and we do COVID screening before we bring in the subjects. And we're starting to implement some of those criteria or some of those safety measures for our driving studies. Once we have that up and running, then I feel confident that we are going to be back on schedule and we're able to accelerate a lot of that. So we're going to maintain our schedule on the breath sensor. We're going to maintain that, the development speed of the sensor, and we look to be able to be done on the consumer-wide sensor by within 2 years. For the touch sensor, as you mentioned, it's a little bit behind, but it's also progressing at a much faster pace. By the third quarter or end of third quarter of this year, we anticipate we're going to have our first prototype installed, either installed or showcased inside a demonstration vehicle that can be used, that we can start testing on. And then we got to deploy these sensors in our internal vehicles for human subjects testing in the clinical setting, but also in our internal vehicles to test them. So we're looking somewhere around the 2024-2025 for commercial deployment for those sensors, for the touch sensors. We anticipate that probably somewhere around the 23-24, you will have a fleet type of version of that touch sensor available, that's ready to be deployed for fleet application.
Great, thank you. Becky, Bud mentioned the $700 cost and indicated that the return on investment by a fleet operator is projected at just a little under 3 years, right at 3 years. You get your money back basically from the prevention of. Expand a little bit on that and tell us maybe how that compares to other in-vehicle technology.
Can you guys hear me? No.
Yes, we can.
Can you hear me now?
Absolutely.
You can, good. My headphones died. They're dead.
Of course.
Of course. So it's essentially looking at the cost of installing the sensor. That was Bud's estimate, and they spent some time trying to understand how much it might on average cost to acquire and install the sensor. And then on our side at Impact Research was the job of understanding how to apply a benefit. And essentially what we do is we combine a bunch of different things. And we have to make a bunch of assumptions. So we have to estimate the number of miles that are driven for fleet operators and how many miles they drive alcohol impaired. And we talked a little bit about that. We had to add in the elevated risk, or how many crashes we'd estimate if they were driving that many miles, and what kind of injuries that they would have in these crashes, because alcohol-involved crashes are generally more severe. And then using these costs that were computed by Zlochnia in 2010, we computed the benefits of savings from crashes prevented from a societal perspective, medical, work loss, and quality of life costs. So, and then you just compute that ratio. And that's what we ended up with. That's how we did it. So it involves a number of assumptions, and I'm sure that depending on the population, it will change depending on the population it's being applied to.
Thank you. And I have one final question in the last 2 minutes we have, and Stephen, I've reserved this for you to sort of close out our webinar, which, by the way, I want to thank all of our panelists for the wonderful presentations and the answers to the questions. Stephen, I'm going to let you have the last word. What advice would you have for fleet managers who might be interested in the DADS program and in participating in a program such as this? What would be your advice to them, given your experience?
That's a great question, and we've had this question come up a couple times when we were testing this process, and someone said, one of our drivers came to me and said, "Do you really think I would come to work, after drinking?" And I said, "Hey, I'm partnering with a state organization. If I thought there was a chance you were going to test positive, I definitely would not want to do this testing process, because it would be really embarrassing to our organization." But as I mentioned before, we have a lot of technology, and it is like Big Brother, watching. And in order for our team, our drivers and everyone else, in order for them to buy into that, big brother watching them constantly. And we're talking about breath alcohol detection, video monitoring, speed sensors, you know, on and on and on. You have to have their buy-in, and it has to be a partnership program, and it has to be part of the culture. Safety has to be part of their, you know, everything we do. And in order for us to get their buy-in, we involved them early on in this process. Bud and his team helped us train the drivers to how to do the breath samples, what to expect, what are some of the things that could come up. What happens? You know, what do we all do? What do our safety managers do when there is a positive? You know, we think we know everyone, but we know there's some surprises every once in a while. So how do we act? But to summarize that, the benefit or the way in how we accomplished that with very little blowback was to involve the drivers early on, keep them part of the learning process, the onboarding process, and the training process. And I think that really makes the difference to get their buy-in. And you know, and for our part, you know, in our industry, obviously, as a commercial driver, their blood alcohol limit it's much lower, and it is, you know, it's pretty much you know, no tolerance for a commercial driver, you know, and this provides that level of comfort. You mentioned it earlier, it's a level of comfort for the manager, and it's a level of comfort for the drivers too. And our drivers care, and our drivers want to be part of the solution, and they want to be viewed by the rest of the world, the non-commercial drivers out there. They want to be viewed as safe drivers, so they want to be part of that whole solution. And because the standards are so much higher for a commercial driver, I think this benefits them and us, and our insurance rates, and you know, everything else.
Yeah, thank you. And obviously, I think that speaks to why JRT was such a great partner with us on this, because of the buy-in that you got and the excitement that your staff had for being a part of it. So we want to thank you for that. Now that is the end of our webinar. I want to say thank you to all of our panelists. I want to thank all of the participants in the webinar. We really appreciate you guys taking the time to attend and asking such great questions. And we hope you found it really informative and insightful. We're obviously very excited about the DADS program, and we look forward to seeing the progress that we make in this life-saving detection system, particularly in fleets. And we couldn't do it without the great work and help of our supporters and partners. If you'd like to learn more about the DADS program and Driven to Protect, or specifically about how fleets can use the technology, please do check out dads.org/fleets. That's DADSS.org/fleets. You can also keep up with the progress of the alcohol detection technology by following DADS and Driven to Protect on Twitter. Now, at the end of this webinar, when you close out, a brief survey is going to pop up. We do hope that you'll take the time to fill it out. It's very brief, but it is helpful for us when we're putting together future programs such as this. And again, I'd like to thank everyone for a great webinar. Thank you for supporting Driven to Protect. Enjoy your day, enjoy your springtime, and hopefully we will get to see you again in person soon. Take care, everybody.
Thank you, everybody.